Hello students, let us continue with chapter 9, areas of parallelograms and triangles. We will take a look at the solved example on page 158. Like I mentioned previously in my preceding video that these solved examples are based on the concept that we learned that parallelograms on the same base and between the same parallelogram and between the same parallels are equal in area. So it's been given that ABCD is a parallelogram. So let's take a look at ABCD. We have ABCD is a parallelogram and EFCD is a rectangle. Also that AL is perpendicular to DC. It's AL perpendicular to DC. Just one moment. I need to prove that area of ABCD is equal to area of EFCD. So the area of this parallelogram and this rectangle, we have to prove that it is equal. So now if you take a look at ABCD and EFCD, they lie on the same base DC and between the same parallels EB and DC. Also you have one parallelogram out here and we know that rectangle is a parallelogram. So we have two parallelograms that are lying on the same base DC and between the same parallels DC and EB. Therefore the areas are going to be equal, right, which is what we learned in theorem 9.1. So let's write this down. I'll say for section 1, first of all I'll say that quadrilateral EFCD is a rectangle. Therefore, quadrilateral EFCD is also a parallelogram, right. Now, quadrilateral ABCD or now parallelogram ABCD and parallelogram EFCD lie on the same base. So what is my same base? It is CD or DC. So I'll say CD and between common parallels. So what are my common parallels? EB and CD. So I'll say EB and DC, right. Therefore, area of ABCD is equal to area of EFCD. So you can say in brackets theorem 9.1, but it's not, you may forget that theorem 9.1 stands for this or that. So just simply write your reason. Since parallelograms on same base and common parallels are equal in area, right. Let's mark this as 1 because we have another section to prove, so we may need help of this. Now we need to prove that area of ABCD is equal to DC into AL. So first let's take a look at ABCD and DC and AL. I have ABCD out here and I have DC as the base and AL here as the perpendicular. So how do I prove that this is the area DC into AL? First of all, we have area of ABCD is equal to area of EFCD. So what is area of EFCD out here? EFCD is my rectangle, its area is going to be what? DC into FC, right? Why? Because this is the length and this is the breadth, correct? But now you have AL also perpendicular to DC, which means that AFCL is also a rectangle. Now since AFCL is also a rectangle, AL is going to be equal to FC because they are the opposite sides of the rectangle, right? So instead of area of my rectangle, so what can I say that AL is equal to FC, then I will substitute, see remember we got that area of my rectangle EFCD was DC into FC, right. So now I will get it as DC into AL. You might have not got this while I explain because it's a little complicated, but once I write it for you, it will become more clear. So let's write this down. the second part, I have area of ABCD is equal to area of EFCD. I'll say from 1. Correct? Therefore, area of ABCD, first of all, area of EFCD is what? DC, that is length, into breadth, which is FC. Therefore, area of ABCD is equal to DC into FC. Let's mark this as 2, right? But AL is perpendicular to DC, correct? And FC is also perpendicular to DC. So why this is perpendicular? Because it is side of rectangle EFCD, correct? Now since we have these two perpendiculars on the same line, what can I say? Therefore quadrilateral, so this quadrilateral out here, AFCL, is also a rectangle. Now since AFCL is also a rectangle, take a look at AFCL. You have the opposite sides AL and FC. So AL is going to be equal to FC. Therefore I will say AL is equal to FC. I'll say opposite sides of rectangle. Right, I'll mark this as 3. So what do you get from 2 and 3? From 2 and 3, instead of FC, you can substitute AL. Therefore, you get area of ABCD is equal to DC into AL. Let's write this down. Therefore, area of ABCD is equal to DC into AL. And why? From 2 and 3. So this is what we needed to prove. So your first section is proved out here, which is point number 1 and section number 1, and we have proved the second part out here. So please take a look at this solution. So this was about the first solved example based on parallelograms on the same on the common base and between common parallels are equal in area. There's another solved example before we get started with the exercise 9.2. Let's take a look at those in the forthcoming videos. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.